In this video we'll look at 6 and 7, which are both solving trigonometric equations, and we're finding all values of theta for which the equation is true. So similar to how we would solve an equation with a variable x, we do want to combine like terms. So in this case, if we add 1 to both sides, those will cross out. We have 4 cosine theta equals 2 root 2. And I want to isolate the trig function cosine theta. So if I divide both sides by 4, this gives us cosine of theta equals root 2 over 2. So on the unit circle, we're trying to find all angles in degrees where cosine is root 2 over 2, positive. So at 45 degrees, we have cosine equal to root 2 over 2. And as well as at 315 degrees, cosine is still equal to root 2 over 2. So here we have two solutions. On part B, I can divide both sides by 3, so sine squared equals 1. Square root of both sides would be sine of theta is plus or minus the square root of 1. So we want to find where sine is 1 or where sine of theta is negative 1. So sine is positive 1 when we're at 90 degrees. Sine is equal to negative 1 when we're at 270 degrees. So number 7 is similar, except we're finding the angle in radians as opposed to in degrees. So in this case, we want to combine like terms. This is negative 1 sine theta. If I add it to 5 sine theta, I get 6 sine theta equals, and this becomes 0. Dividing both sides by 6 gives us sine theta equals 0. And so we're finding all the radian measures where sine is equal to 0, which would be here at 0 radians and at pi radians. And here on part B, I can divide by negative 4, which gives us cosine of theta equals root 12 divided by negative 4. And square root of 12 can be simplified. This is 4 times 3, so that would be 2 root 3 over negative 4, which simplifies to negative root 3 over 2. So I'm looking for where cosine is negative root 3 over 2, which would be here at 5 pi over 6 and at 7 pi over 6.